In this video, we're going to talk about the exterior angle inequality. Start off with a definition. Given the triangle ABC, which I'm going to go ahead and draw, I'll put A on top, B here, and C over here, and a point D such that C is between B and D. Well, if C is between B and D, D has to be out here somewhere. So since they are collinear, C is in between them. I'll put D like maybe right there. All right, well, this formed an angle called ACD. And what we call this, since it's not internal to the angle, the triangle, it's outside of it, this is an exterior angle to this triangle. Exterior angle. Okay, and notice that two of the interior angles are opposite of this one, right? This one uses point C. Well, angle A and angle B are considered opposite interior angles of this external or exterior angle. All right, there are other exterior angles as well. I could have extended this way. And then if I did, this angle would have been an exterior angle, and it would have had these two opposite interior angles, angle A and angle C. All right, the exterior angle inequality in absolute geometry. Just remember that right now, absolute geometry is very similar to the normal Euclidean geometry we learned in high school, but it does not assume the parallel postulate is true, and we will talk more about that later. All right, well, it says that an exterior angle of a triangle has an angle measure greater than that of its either one of the opposite interior angles. So in my picture, it obviously looks like that. You shouldn't trust pictures, though. Notice that this big exterior angle is bigger than, the measure is bigger than both of the measures of these two angles. So we're going to use that to determine whether these four triangles exist in absolute geometry, and we'll sketch them also. So the first one is a triangle with these three angles, 100, 45, and 32. So if we draw something like this, make this one 100 at the top, that looks like the biggest angle. And this one is 45, and this one is 22. Yeah, my drawing's not very good. But let's see if that exists. Well, let's say we do this. Let's extend this angle. All right, if we extend it, now we have an exterior angle. And we know what this angle is. We know exactly because this is a straight line. So these two angles are supplementary, which means they add up to 180. So this one would be what? Let's, well, that's actually a 32, not a 22. So if that's a 32, 180 minus 32 would give me 148. And the question is 148, this exterior angle, is that greater than the two opposite interiors? And it is. 45 and 100 are both less than 148. But we got three other angles to do as well. And I'll extend this one, which would make this angle 80. Because these two are supplementary, so add up to 180. Is 80 greater than its opposite interior angles, the two of them, 45 and 32? Indeed it is. One more to check. I'll go like this. And let's see, if that's 45, this angle would be 135. And the question is 135 greater than the two opposite interior angles, 132? Indeed it is. So yeah, this one satisfies. That one is a triangle in absolute geometry. And now let's do this one. 55, 55, 55. So 55, 55, 55. We'll actually only have to test one because they're all going to be the same. All the exterior angles are going to be whatever this is. And these two angles are supplementary, so 180 minus 55 gives you 125. And 125 is greater than 55, so yes, it works, and all of them would work as well. So that's a yes. How about this triangle where we have a similar situation? All the angles are the same. 93, 93, 93. So we'll only have to test one on this one as well. Oops, it's off the camera there. If this is 93, then this, which is these two make supplementary angle pair, this would have to be 87. Is 87 greater than its two opposite interior angles? 93, no, it is not. So this one is a big no. This triangle doesn't exist in absolute geometry. All right, last one of these. We've got two 92s and then a 5 up here. Well, let's try this. This angle has to be 88 because these two angles are supplementary. They add up to, now they add up to 180. 88 is greater than 5. Is 88 greater than 92? No, it's not. So that one doesn't exist either. 2 yeses, 2 nos. In the next example, we're going to draw a triangle PQR. Draw that where the measure of angle R is 35 degrees. Not too bad. I probably drew it a little bit bigger than that, but you trust the numbers. That's 35 degrees. Use the exterior angle inequality to find an upper bound for the measure of angle Q, for this one right here. Okay, well, we're going to use the exterior angle inequality, so I'm going to extend that to get an exterior angle right here, which I know the value of. Since this is 35, this one is going to be 180 minus 35, or 145. Well, this external or exterior angle has two alternate interior angles, Q and P. So we know that, we're not going to care about P, we only care about the measure of angle Q. We know that 145 has to be greater than each one of those. So 145 is greater than the measure of angle Q. So I'll write that the other way around. I'll write the measure of angle Q is less than 145. That means that 145 is an upper bound for Q. It's greater than or equal to, in this case. So measure of angle Q is less than 145. That's our upper bound. Now let's do something similar in number 4. Okay, find upper and lower bounds for Y in the figure. So eventually we're going to have something like this. Something is less than Y is less than something. This would be the upper bound. That'll be the lower bound. Our final answer is going to look like this. Okay, so remember that linear pairs of angles add up to 180. And these are all that we've seen before. These are linear pairs, like this here. And linear pairs are supplementary, so they add up to 180. Well, what can we get using the exterior angle inequality? Well, let's write down what this is. This angle. That's an exterior angle. And if that one's 50, this one has to be 130. And while we're doing it, let's go ahead and write this exterior angle. If this one is 70, this one has to be 180 minus 70 is 110. Now let's just use the exterior angle inequality. Note up here, I'll write this down, that y is equal to the measure of angle MLK. All right, so this angle is an exterior angle to this triangle, MLN. This is an exterior angle. So we know that y is greater than this angle, which we don't care about, and this angle, which we know. This is greater than 50. All right. Now let's note that this angle here is an exterior angle of this triangle. So 110 is greater than both this angle and y. So 110 is greater than y. I think that gives us exactly what we need. So now we have, I'll write it down here, and actually up here I should have called this the measure of angle y here. I'll write it down here. The measure of angle y. It's greater than 50, which means this. 50 is less than the measure of angle y, and the measure of angle y is less than 110. Therefore, we found an upper bound, which is 110. It's no more than 110. And we found a lower bound of 50. It is no lower or less than 150.